Hello everyone, I am Alisha Malik in front of you again with our channel Zero Vision. Higher than the mountain Everest? Is this possible? Still now, we have learned about only the Mount Everest, which is the highest mountain of the world. But more than that, which is this mountain and from where this mountain came suddenly? In this video, you will get the answer of all questions. Mountain with peaks 3 to 4 times higher than Mount Everest have been discovered deep inside the earth. Using seismology centers in Antarctica, experts found these astonishingly huge mountains in the boundary between the core and mantle. Around 1800 miles deep, around 2900 kilometers. Dubbed ultra-low velocity zones, these gargantuan underground mountain ranges had managed to escape. The scientists gauged all these years until earthquakes and atomic explosion generated enough seismic data to be spotted by them, reported BBC. To make sense of how big these mountains are, Mount Everest is around 5.5 miles high from the surface, while the underground mountains are said to be over 24 miles in height. Analyzing thousands of seismic recordings from the Antarctica, our high-definition imaging method found thin, anomalous zones of material at the CMB. Everywhere we probed, Arizona State University geophysicist Edward Garnero said in a statement, "The material thickness varies from a few kilometers to 10 kilometers. The material thickness varies from a few kilometers to tens of kilometers. This suggests we are seeing mountains on the core, in some places up to 5 times taller than Mount Everest." Now the question is, how did these mountains form suddenly? One possible explanation given by the scientists is that these ancient formations were created when oceanic crust were forced into the Earth's interior. They argue that it might have begun with the tectonic plates slip down into the Earth mantle and sink into the core mantle boundary. This then slowly spread out to form an assortment of structures, leaving a trail of both mountains and blobs. This would mean both are made from ancient oceanic crust, a combination of basalt rock and sediments from the ocean floor, albeit transformed by intense heat and pressure. Next question would be, what does the discovery entail? The study seeks to argue that these underground peaks may play a critical role in how heat escapes the Earth's core. The core is responsible for generating Earth's magnetic field, and some of the material from it can even be ejected up to Earth's surface during volcanic eruption. Seismic investigations such as ours provide the highest resolution imagining of the interior structure of our planet, and we are finding that this structure is vastly more complicated than once thought. Study co-author and University of Alabama geoscientist Samantha Hassan said in a statement,